Hello, welcome to this video 4.7. We're going to solve equations with rational exponents. Our learning target is to solve radical equations, and our success criteria is knowing the order of operations and can reverse the order of operations to solve an equation, as well as evaluate an expression with a rational exponent. Some concept development in vocabulary. An equation with rational exponents is a type of radical equation, and when solving these equations, it usually is easier to leave them in the original form than rewrite them in radical form. Here's the steps we're going to use in order to solve a radical equation with rational exponents. We'll reverse the order of operations, starting with addition and subtraction, undoing these operations on the outside of the radical. And we'll use, again, this phrase or acronym to help us remember the order. SADMET, we'll undo addition and subtraction, followed by multiplication or division. And then we'll undo the exponent. And then we'll go ahead and we'll do the reverse order of operations, SADMET, with any operations that are occurring outside of the radicand, inside of the radicand. Lastly, we will have to check our extraneous solutions and then write the final solution. So let's go ahead and look at the first example. X to the power of 3/2 equals negative 64. In order to undo this rational exponent, all we're going to do is raise our expression on both sides with the reciprocal exponent. X to the power of 3/2, I'm going to raise it to the power of 2/3. Now when I have a power to a power, we end up canceling these exponents and we're just left with x. Now what you do to one side, you have to do to the other. So we get x is equal to negative 64 to the power of 2/3. Now we'll evaluate this in radical form. So the cube root of negative 64 raised to the power of 2. The cube root of negative 64 is negative 4. And we're going to square the negative 4, which gives us 16. Now, usually when we square a negative, this is a red flag and it will result in an extraneous solution. But let's go ahead and check. So I have my original equation, x to the power of 3/2. So 16 to the power of 3/2. What is this? Well, the square root of 16 is 4. 4 to the power of 3 is 64, which is not equal to the right side, which is negative 64. So this solution is extraneous. Extraneous, if I can spell. Our answer, no solution. Let's look at example 2. Here we have more going on than just an expression raised to a power. We have 2x to the power of 2/3 minus 1 equals 15. We'll go ahead and add 1 to each side, giving us 2x to the power of 2/3 is equal to 16. Then we'll go ahead and now we're going to undo this power, because notice that I have 2x on the inside. It's all of the 2x, so do not be tempted to divide by 2, because that power is applying to both. So here we'll go ahead and we'll raise each side to the power of 3/2, raised to the power of 3/2, which will cancel our exponent, leaving us with 2x on the right-hand side, and on the left-hand side. And on the right-hand side, we get square root of 16 raised to the power of 3, which gives us 64. And then we'll go ahead and we'll divide by 2, giving us x is equal to 32. Now we'll go ahead and we'll check this. So if I plug this in, we get 2 times 32 raised to the power of 2/3 minus 1. What is this? So 64 to the power of 2/3. The cube root of 64 is 4 squared, gives us 16 minus 1. And is that 15? It sure is. So there is our answer. I have 2 practice problems here for you. Please pause the video and try these 2, and I'll go over the solutions here in a moment. All right, here are the two solutions to the practice problems. Very straightforward. The first example, you just raise both sides to the power of 3/4, canceling the exponent. You get 81 to the power of 3/4. The fourth root of 81 is 3. Raise to the power of 3 is 27. And when you evaluate this, you get a valid solution. On the right-hand side, we have 3x to the power of 3/4. So I'm going to start by raising both sides to the power of 4/3, canceling the powers. The third root of 27 is 3. Raised to the power of 4 is 81. 3x equals 81. Divide by 3, you get 27. Not too bad. So hopefully you did well there. Okay, let's go ahead and look at this next example. Here we have a coefficient, 3/4 times x raised to the power of 4/3. The first thing I'm going to do is I'm going to undo the multiplication and division of this coefficient. Notice this is different than the example above because I don't have parentheses around that 3/4 and the x, indicating that the power is a part of both terms. It's just, the 4/3 is just attached to the x. So I'm going to cancel this fraction by multiplying by the reciprocal. So we'll cancel our coefficient on the left-hand side. So we have x to the power of 4/3, and we have 12 times 4/3. I like to divide first. 12 divided by 3, that's 4. 4 times 4, 16. 16. Don't be scared of the fractions. So now we'll go ahead and get rid of the power by using the reciprocal power. That's kind of the moral of the story for this lesson. We have 3's that cancel, 4's that cancel, and we get x is equal to the fourth root of 16, which is 2, raised to the power of 3, giving us an answer of 8. And we'll go ahead and check this. So 3/4. 3/4. Times 8 to the power of 4/3. So here, using good old, please excuse my dear Aunt Sally, we're not using SADMAP because we're evaluating this. The third root of 8 is 2. So 2 to the 4th, that's 16. And 3/4 of 16. 16 divided by 4 is 2 times, and it's 4. It's 4, not 2. Gives us 3 times 4, which is 12, which equals the right side. So this answer is valid. All right. Here's a practice problem. Please go ahead, pause the video, and try this one. All right, here is the practice problem. We have, after multiplying both sides by -2/5, the reciprocal, you end up with x to the power of 3/2 is equal to -8. And then we'll raise both sides to the power of 2/3 to cancel that exponent, giving us x is equal to 4. Now this is extraneous. This is extraneous because when I plug in 4, we have 4 to the power of 3/2. That's the square root of 4, which is 2, raised to the power of 3, which gives us 8. Times -5/2 is going to give us a -20. 8 divided by 2 is 4, times a -5 gives us a -20, which does not equal the right side, which is a +20. So that's why it's extraneous. Okay, last example and practice problem for this lesson. Here we have one that's more involved. I have a coefficient of a -3 on the outside. So that's the first thing that we're going to undo when we're solving this equation. We'll cancel the -3's, giving us 3x plus 5 to the power of 2/5 is equal to a +4. We'll go ahead and undo the powers by raising both sides to the power of 5/2. So those exponents will cancel, and we get 3x plus 5 is equal to the square root of 4 raised to the power of 5. So that's 2 to the 5th, which is 32. And now we have 3x plus 5 equals 32, which is a good old two-step equation. So we'll take away 5 on both sides, and you get 3x is equal to 27. And then we'll go ahead, we'll divide by 3 on both sides. And we get x is equal to 9. Let's go ahead and check this solution. So I'm going to plug it into the left-hand side. We have 3 times 9. That's 27 plus 5 gives us 32. So all of this is raised to the 2/5 power. to the power of 2/5, okay? And then we multiply times 3. So the fifth root of 32 is 2, so 2 squared is 4, and we get 12. Oh, well, I have a negative 3 on the front, right here, negative 3. So negative 12, does that equal the right side? It does, so this is valid. All right, last practice problem. Try this one, pause the video, and then I'll show you the solution here in a second. All right, in this example, you go ahead and subtract 4 first, giving you 2x plus 5 to the power of 3/2 equals 8. Then you'll undo that expression by raising both sides to the power of 2/3, canceling that exponent. So you have 2x plus 5 equals 8 to the power of 2/3. The cube root of 8 is 2. 2 squared is 4. So you have 2x plus 5 equals 4. We'll subtract 5 from both sides, giving you 2x equals -1. Divide by 2, you get x equals -1/2. When we plug this into our original expression, we get a valid solution. All right. Hopefully in this video, you learned how to solve radical equations, specifically with rational exponents. Give me a thumbs up, like, subscribe. Catch you in the next video. See ya.